before we go to JavaScript and beyond JavaScript, I would like to tell you a story. So the story is about the Piraya people. It's a tribe, native tribe living in the Amazon basin in Brazil. And they are really famous. And they are like not kind of mainstream famous like Brad Pitt, but more like niche famous like Dan Abramov. So because they are famous amongst language researchers, obviously because of their language. Uh, their language is important because it has a lot of limitations that we didn't think it is possible. There were like language theorems saying that basically no human language could be constructed this way. And those limitations are so far-reaching, like they don't have past. Like they have no way of talking about something that happened 2 weeks ago, 2 years ago, 200 years ago. So they don't have history. They don't have any origin myths. They don't have eternal enemies that they've always been at war with, because there's no way to talk about those things. They don't have ghosts of their ancestors, because they don't really have a word for an ancestor. They have a word for a parent, and they have a word for a sibling, but they don't have a word for a cousin or an uncle or a grandfather. So they also cannot talk about future. This concept doesn't exist, so you cannot talk about what's going to happen after you die. So basically, there is no religion, because there is no heaven, no hell, nothing like this. For us computer scientists, it's I think most interesting is that they don't count. Like they have two words, hoi and hoi, which like the only difference is an accent, and one of them means a little and the other means a lot. Obviously, those terms are super relative, and they are also relative in their language. Like you showed the same pile of stones and ask one of them if it's a small amount of stones or a big amount of stones. Like depending who you ask or how you primed them before, like showing different piles of stones, they will tell you two different things. Or the same person will give you two different answers at different times. They also don't have colors. If they want to say something is red, they say it looks like blood. Something is blue, it looks like sky. Like they have workarounds for all of those things. But I don't really want to talk about their language. What's more interested for me for this talk basically is their boats. So as you see, they are not particularly complicated, and you can imagine they would be able to do it themselves. And I mentioned that they live in the Amazon basin. Like what you probably know about the Amazon River is that the piranhas live in the water. So boats are important for them for fishing, for transportation. They cannot just like swim around. But what's curious is they don't really build them themselves. They buy them from other tribes. And there is this language researcher called Daniel Everett who's been living with them basically for 20 years now. It's like a completely crazy story just about him. But basically, he's been spending so much time with them that he felt like, I would like to help them live an easier life. So what's a thing I could do for them? He felt like, I'm going to teach them how to build boats themselves so well, let's not cheat ourselves. Like the tribe is 150, maybe 200 people. So they are not an economic powerhouse. They cannot count, so trade is a bit difficult. So they're probably like paying too much for the boat, so they could build it themselves. So he hired a craftsman from a nearby town to come and work with them on the boat. So he helped them construct them, and like they were working together. And at some point, the craftsman says, "Yeah, like they know everything they need to know. Like I'm going home." So they were using the boats that they built with him for a long time, like for some time. But when they eventually broke beyond repair, they did what they always did. They went to the other tribe and bought some new ones. So Daniel Everett got obviously angry, and he's like, dude, like I spent all this time, all this effort. I got you a guy. He taught you how to build boats. Why didn't you build boats? And the answer was super simple. We are not the kind of people who build boats. So why did I spend all this time telling you about native tribes in Amazon when we're supposed to talk about JavaScript? Well, I think it's connected. We as much as some of us can love JavaScript, it has a lot of limitations. And I think what I want to talk about is that it's important for us to see those limitations as something that we can overcome. And if we choose to embrace them and live within their limits, then it should be our own decision. It shouldn't be something that everybody's been doing all the time, and we don't really need to learn how to count. Our grandfathers, sorry, our fathers were living like this, and we can it's not about. Sometimes you just don't need a workaround. You need a proper solution for a problem, and that's kind of what I want to talk about. Before React Native, so. The thing is that a lot of recruiters who write me on LinkedIn trying to get me pushed into some kind of company or another, they seem to confuse React.js with React Native. And I can see how they can appear similar, but for me, they're a completely different thing. React doesn't interest me at all. I mean, React as a JavaScript web framework doesn't interest me. I'm kind of old and I don't do web, so the last web JavaScript framework that I was excited about was around the time when jQuery came out. And it's not that it's just not the thing I do. But React Native is a completely different story. One thing is that if any of you tried to do some native mobile development, you probably already have unfortunate knowledge of this thing. But if you didn't, the development tooling for mobile is terrible. Xcode crashes all the time. Android Studio is just ugly. Build times are crazy. And bringing React Native into this ecosystem was like a breath of fresh air. When mobile developers see hot reloading, they're mind blown completely. Instead of clicking the build button, waiting 2 minutes for the build to finish, and then starting at the beginning of the application to click through the state that where you change the margins by 5 pixels, when you hot reload, your situation is completely different. The whole tooling problem, with iOS, you kind of depend on Apple caring about Xcode. Well, sorry, let's not pretend Apple is caring about Xcode. The world when your tooling is open source and people actually fix it all the time, and you can fix it yourself, it's something completely. It's another world. So this is what React Native brings to mobile, in my opinion. But the second thing is that while for me React.js is just a framework, it's just another way of doing things, React Native is more of a platform. It's not a platform that lets you build mobile applications in JavaScript. It's a platform that lets you build mobile applications in any language that compiles to JavaScript. And this difference is huge because, well, a couple years ago, I checked. I wanted to know how many languages there are that compile to JavaScript. And the longest list I could find was on the CoffeeScript wiki page. And there was more than 300 listed. And that was 2 years ago. So we have, for our disposal, hundreds of languages that we could, theoretically, use for React Native development. So why don't we do it? Well, the thing is that we have some kind of tribal mentality where the programming language is part of our identity. It's not the tool that we use. In programming, I think, world is that there are things that we can change and we rationally evaluate if it's a good idea or not. For example, is it a good idea to put all my backend on Docker and deploy it? you can test it. You're not emotionally connected to this thing. Like it's just a tool. We use it or we don't use it, but like we're not super passionate about it. On the other hand, we have things like tabs and spaces. There's no rational decision there. It's all about emotions. So I think, unfortunately, programming languages fall into the spectrum of emotion, while it should be falling into the spectrum of it's just a tool that we use. So imagine we're some kind of detached from, well, one more comment about it, because it bothers me all the time. We tend to identify ourselves as some kind of language developer. Like, I used to write a lot of Ruby, and the term Ruby developer in the Ruby community, it means I do web apps, but I don't use PHP like the other people. It's like, if you see somebody who's identified as a Swift developer, it means I do iOS, but not for your Objective-C legacy code base. Like, I'm not going to touch it. It's this negative definitions that bothers me. It's like we should be like embracing what the other communities do instead of like distancing us as some kind of elitist jerks. Anyway, science. This is how we should be choosing our programming languages. So the way you would go about it is super simple. You take 20 programmers, you define them randomly into two groups. One group uses language A, the second group uses language B. You give them the same specifications, you give them 3 months, and you come back and look at the two projects and figure out which one is better. And then you know like which language is better. Simple, right? Except let's just like skip over the part where you judge which project is better, because this is difficult by its own. But it was 3 months, 20 developers. It doesn't give you a solution. It gives you one statistically insignificant data point. So you should repeat this study, I don't know, 5 times, 10 times, 20 times. And this gets really expensive, because good developers are expensive. And the society that we live in has decided, by putting the market value on the developers, that their time is probably better spent instead of doing academic studies. They should be better off working for companies like Facebook, making people click advertisements on the internet. So we cannot really do that, right? Because we don't have the budget. But fortunately, there are people who really care about it. And there's a name that I'm going to butcher because I don't have my speaker notes here. It's Lutz Preschelt, I think. He's a university professor here in Berlin. And he does studies about developer productivity, programming languages, different coding styles, and so on. And in one of his studies, he determined that developer productivity is constant in terms of amount of code that you're able to write during a day. So what it means in practice that if you're writing an assembler, you're kind of like 200 lines of code developer, then you're gonna write 200 lines of assembly. And if you're writing JavaScript, you're gonna write 200 lines of JavaScript. It's the same kind of mental effort. But 200 lines of JavaScript do a lot more than 200 lines of assembly. Like, there might be good reasons for choosing assembly if you care about performance. You want to do like particular operations in the processor, but usually when you just want to get stuff done, like, you would go for JavaScript. And this is important for us because it takes away one thing. Like, a lot of us intuitively know that like if you're using Java and your hello world has 10 lines, and you're using JavaScript and your hello world has 1 line, then probably you would be faster writing in JavaScript. And here, like, you have a scientific proof that that's actually true. Like, if you spend less time writing the code, you're gonna create more of it and create more features. Another study, it was done in 2001 on the University of Ottawa, was into metrics of finding bugs. Basically, there's an important question that we'd like to have answered, which is, if I look at a piece of code, I would like to know how many bugs are there. And without having to find them specifically, because then it's too late because I already know. But I would like to know before. Like I take a look at a piece of code, it's like, it looks like there are 4 bugs. I don't know where, but let's keep looking until we find at least 3. So there were a lot of metrics, like how coupled code is, how big the classes are, and so on. But this study done in Ottawa determined that basically all those metrics are totally useless because you could they have the same value as just counting the lines of code. So you could do something just as simple as just run a word count on it, and you will have your answer how many bugs there are because it's proportional to the code. One important outcome, apart from setting some kind of chimpanzee scale for the metric, chimpanzee scale is like when you have a test and there's multiple answers, and there is a point, how many points a chimpanzee would get, filling it out randomly, right? So it turns out that all those metrics were below this threshold. They were basically useless. But the second thing that's more important for us is that now we know that if we have a language that allows us to write less code, we're going to have less bugs, which is, for me, it's mind-blowing. It's kind of intuitive. It's cool that we intuitively understand it, but it's like science has spoken. But there's some studies that you could do yourself in your own home about stuff that's the really important subject for us, which is the eternal fight between dynamically typed languages and the statically typed languages. And I'm not going to tell you where I stand on this issue because it's controversial, but I have a little movie about a dynamically typed zebra and its misadventures that might tell you my opinion. OK, so there was a study somebody did, a random person on the internet did somewhere in September. What they did was they looked at the GitHub API. They found they were only interested in JavaScript commits, only in those commits that are that obviously fix something. By the commit message, you can see it, fixes, I don't know, bug or something. And they took 400 of them, all of them pretty small. The average size was between 5 and 7 lines of code. And what they wanted to know is that would this bug be detectable if instead of using pure JavaScript, somebody would be using Flow or TypeScript in their project? Because they wanted to figure out which one is better, which one fights more bug. So out of those 400 cases that they tested, they got to a conclusion that 60 of those bugs would be preventable if you would use some kind of type-check language. And now it's important moment of our analysis. We have a data point. Let's pretend we did the study. And OK, so now we know that if we switch our project to TypeScript, we're going to have 15% less bugs. Is it a lot? Is it a small number, a big number? Should we do it? To put it into perspective, we all agree that we should be writing unit tests, right? Yeah, we do. I'm not saying we write them. I'm saying we all agree that we should. It's safe to say yes. So there's a bunch of studies were summed up in a Code Complete book by Steve McConnell, I think. But basically, they say that unit tests can find 25% of the bugs. So we have something that everybody knows is a best practice, like unit tests, and it's 25%. And so our 15%, I think, is it's a significant number. I would be more happy with types. What's an interesting tidbit of knowledge from this on the side is that the most useful way of finding bugs is just making a code review, because it's able to find 60% of them. So if you have a choice between doing the code review or writing tests, your time is going to be better spent doing the code review. Anyway, but it's pointless about talking all of this, because we know that premature optimization is the root of all evil, right? We all know this phrase. We all use this phrase whenever somebody told us, like, maybe you should do it this way. I'm like, no, 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 that's premature optimization. Basically, this quote is used for describing stuff that I know I probably should have done, but I don't really want to. Like, we say, no, no, it's premature. But the thing is that this quote has a larger context. The whole sentence that Donald Knuth wrote was, we should forget about small efficiencies, say about 97% of the time. Premature optimization is the root of all evil. However, we should not pass by the improvements in those critical 3%. So it's not about like that we shouldn't be optimizing stuff early. We shouldn't be optimizing the not important stuff. And I think like if a small, well, not a small language change is not a small change, but if a change can give us like 15% lower bug rate, it's probably in this critical 3%. Anyway, so this is the part of the talk where I tell you what kind of language to use, right? Like, did the intro, I set up the expectations, and now I tell you. Like, of course, like the answer is super simple. It depends. Choosing a programming language is not a technical decision. It's a business decision. And unless, well, even if you're doing open source, it's a business decision for the project because it influences its future. And what I would like to talk to you about is that what the options are, because like I don't know nothing about like what you should be using for ReactJS, but I've been doing a lot of React Native, and I've been talking to a lot of teams that do React Native, and I know what choices are kind of safe. I know what might be interesting, and that's what I wanted to share. So a really safe choice just to use TypeScript, because it's the interoperation with React Native is super simple. You just have some Babel transpilers, and it all fits in really well, the whole tooling. And the change is not that big for the team. But much more interesting choice that like is much more surprising is Clojure script. Turns out that the Clojure script has really nice tooling that's completely like parallel to the normal JavaScript tooling. And a lot of teams who are like, I imagine a team that's like Clojure on the back end, Clojure script on the front end, and the product owner comes and says like, yeah, I would like a mobile app by the end of the month, if you may. Like, they're not gonna go and learn Swift. They're not gonna suddenly start writing JavaScript. Like, there's a reason why they were writing Clojure script in the first place. So a lot of those teams go for Clojure script, and they're successful with it. Like, if you're more comfortable with Clojure than JavaScript, it's a safe choice. If you want to be more productive and you already know Clojure, it could be a nice choice because Clojure is, I think it's more expressive. So there are like less lines of code, so less bugs, more productivity. So if it's something that you like, it could be a nice option. But I want to talk about the third option, which is my personal favorite recently. And I'm going to do a short demo. So, OK. So we have is code visible in the back? Yes? OK. So we have like, my company from Barcelona. By the way, we're called Brains and Beards. It's a super cool name. So the example application is a simple recommendation guide for Barcelona. So you have like a bunch of stuff that you can scroll through. That's it. It's not particularly sophisticated. But there is a mix of like stuff that you can go and see, and make of places where you should go and eat something. And I would like to have some category switcher there. So what we're going to do is like in terms of normal React application, in our component, we would add some internal state that holds what kind of filter is currently active, and we'll use it to filter the recommendations. So we're going to do it in Reason. So first, we would start with defining what the state is going to be. So I'll need the type for that. And it's just going to hold the filter. And I did some prep work before, so I can just do this one. Category is some kind of namespace, because it's a different file, and filter is a type. And because it's all reasoned, my ID knows what kind of type is it. And it's a variant, which means the filter is either some kind of category or like just all of them. So that's a start. The second thing that we're going to do is when we're defining the component, we're creating as a stateless component, because at the moment it doesn't have any state. But we'd like to make it a reducer component instead. And this is a concept of telling reason React is a library that connects like reason with React, obviously. Anyway, we did this, and now we have like this is like a compiler output on the right. You don't have to read it, but basically like there's a bunch of text that tells me, oh, I see you're creating a reducer component, but so I know it should have state, but you don't hold any state, you're not using any state, like you should fix this stuff. Or otherwise switch back to the stateless one. So we're going to implement it. So we'll have some initial state, which is going to be a function that basically returns the initial state, which is going to be all the categories. And now we would like to have, because the way recent React works is that if you have a reducer component, you get like a cute little mini Redux inside. It's not like in JavaScript where you would like write set state everywhere in like random place in your file. Like here, no, we're gonna be reasonable about it. We're gonna create a reducer function. We're gonna map some actions, and we're gonna dispatch them and do all this stuff. So I'm gonna have a reducer component that takes action and a state, and does stuff with it. But we have to know what the actions are, right? So let's define a few of them. So I'm going to use a variant here. Like there are two possible actions. Either we set some category or we clear them. So one of them would be setting at a category, and this is an action that is gonna take a category that we're gonna set. It's like basically what I'm doing is creating a variant with constructors, but I don't have time to talk about it all. Hopefully Marcel is gonna explain it really nicely. But what we in the next talk. But what you really know here is like there are two options. The action is either this or that. Like we don't handle anything else. So we can go back to our reducer now. Switch. And we can do a switch between the different actions. This is different than the switch in the JavaScript because it's called like pattern matching, which is really cool because it allows us to say if the action is set category, then it has some value category, and it already assigns it to some kind of variable that we can use directly. I think I have a syntax error somewhere. Let me just double check. Yes, I do. Now's the tricky part. Yeah, but I have it.
I mean, line 29, reducer, and then column.
Ah, yes, obviously. Thank you. You're a lifesaver. So we have the set action where we set the category. So what we should do here is we call the update function from reason React, and we pass a state that we're going to use there. So in our case, the new filter is going to be just this category. And what's interesting here is that you could see like the compiler tells us about stuff that normally a linter would tell us. That like except the compiler knows all about types, and it's not like a linter is a separate tool. It's like we get a compiler warning telling us, okay, this pattern matching, I see you're matching actions, but you only took into account one of the options. You have to tell me what to do when there's the other action. So, and he's right, obviously, because he's the smart one. I need to handle the other action as well. So I'll do a similar thing. I'll just set up and filter as all. So there's another thing that he tells me about, dude, here you're declaring the variable state, but you're not using it. Do something about it. And with JavaScript, I could just delete it, but this is gonna be super bad. We're in a reasonable language. It's not JavaScript. The variable is there for a reason. Anyway, I'm gonna stop now. So we just put an underscore in front of it. It's like a functional programming pattern where you mark stuff that you don't care about. So we have some setup. We have a state. We define some actions. We have a reducer, but we're not using it for anything. So there's just some final changes where I would get the declare a current filter, get it from the state. Now I can use it into pass it here. It's a function you don't have to, it's a value that you don't have to worry about. It's about how I get my recommendations. And the last thing that I have to do is to create some kind of switcher between different categories. So just some JSX. I create a view, and I have for the button, I have a component that I created before, and I call it category. I just don't remember how I use it, but obviously types everywhere. So it tells me, OK, you need to pass a filter, what kind of filter this button is going to represent, a current filter, so it can determine if it's the active one, and some kind of on-change callback. OK. So we're going to pass a current filter, and the value is going to be current filter. So this filter is going to be about displaying all of them, and on change callback. Now it gets tricky because the callbacks on clicking stuff is there are functions that take an event because the event that the click happened, and they return a void object. And here I would like to return an action somehow. So I have to wrap it all around using a reduce method that comes with that basically Region React makes it available for me. So I can create some kind of callback that will play along with all those types. So it will take an event, and for us, this one would clear all the categories. OK. I don't know if you noticed, but before I wrote current filter equals current filter, which I felt stupid doing so, and this is the reason formatter fixed it for me, because I can just say current filter, and if the variable exists, it will be populated with it. And there's another thing, I mentioned that with reason you have the linter coming in the package because of the compiler warnings. You also get prettier coming with it because you have the reason formatter that takes care of how the code looks. And this is a wonderful thing, but probably we all know it because we're using prettier. And if we're not, we should. But no, seriously, lifesaver. Anyway, I'm just copy-pasting here the other buttons. So they're going to be setting a category for stuff to see. Oh, sorry. And we need also stuff to eat. OK, so now I reload the application, and it's cool. First, we have all of them. Nice. Just stuff to eat. Cool. We save stuff to see. This is not a bug. There's a food in the picture, but it's not a place where it's a place where you go to watch food, not eat food. I wouldn't recommend it. Anyway, what you might have missed is all the time that I was working on this small feature, I wasn't looking at the emulator at all. Like I opened it in the beginning to show you what the app is and what I'm trying to do, and I opened it at the end to show you that it works. And I knew that it works because of my little pair programming buddy that's here in the terminal, and it tells me all the time like, you're wrong, even worse. Okay, now it's fine. So for me, it's a much better developer experience where I can be like typing code all the time, and whenever I save, it compiles automatically. It tells me where the bugs are. Also, the messages are super cool. I don't know if you noticed, but there's. Okay, I just finished. Basically, they tell you, we found a bug for you, which is a positive thing, instead of you're wrong, which is a negative thing. It's like all the small stuff is cool for me. Anyway, wrapping up the thing. So, use reason, I bless it. No, there are like bad things about it and cool things about it. If you want details, like talk to me afterwards. I'm already over time. Cheers.